So for our third lesson of Unit 1 in our Open Up Algebra 1 is this lesson called Growing Dots, which is another Develop Understanding lesson. So for our learning focus for this lesson, model a sequence of figures using tables, graphs, and equations. Very similar to the last one that we worked on, right? Still using those tables, graphs, and equations, but we're going to be working with a different type of sequence this time. Okay. So here's our pattern now. And again, you're tasked with describing and labeling the pattern of change that you notice. And I'm going to ask this question again because it's just so important for this unit. As you're labeling your pattern, take note of the minute and how you can relate the minute that you're on to the pattern of growth that you're seeing. And so many students right off, they notice that each minute has these three groups. And so students should begin to think like, oh man, how can I relate the minute that I'm on to one dot in each group? Or 2 dots in each group. How is that related to 1? How is 4 dots in each group related to 2? How is 8 dots in each group related to 3? How is 16 dots in each group related to 4? This is the major breakthrough of this lesson. Once you realize this idea, this concept, you begin to think about your sequence. So our sequence, our first term is 3, right? At the beginning, we have 3 dots. And then we have 6. Okay, and then we have 4, 8, 12. Then we have 2, 8, 16, 24. Then we have 16 plus 16 plus 16 is 48. So our sequence 3, 6, 12, 24, 48. How do you see this pattern growing? You should notice each term is being multiplied. The previous term is being multiplied by 2. So our change factor, our growth factor, turns out to be 2. Assuming the sequence continues the same way, how many dots will there be at 5 minutes? Well, we have 4 minutes. What's our next one? We need to multiply that by 2, right? You arrive at 96. 96 dots. Model the sequence of figures using a table, graph, and recursive/explicit equation. All right. So here is T for time and D for dots. Well, at time equals 0, right? I believe that was 3 dots, right? And then at time 1, I have 6. At time 2, I have 12. So on and so forth. So for T dots, what is my equation going to be? Well, let's go back to our pattern. We start at 3, and our change factor is 2. And we notice that what is the relationship between 0 and 3? What is the relationship between 1 and 6? What is the relationship between 2 and 12? So on and so forth. Well, we can begin to see this by focusing in on just like one of these groups here. So how is 1 related to 2? How is 2 related to 4? How is 3 related to 8? Well, these are the powers of 2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8, right? So if we just focus on just one of them, well, these are the powers of 2. How is 1 related to 2? It's 2 to the first power. How is 2 related to 4? It's 2 to the second power. How is 2 related to 3? how is 2 related to 4? That's 2 to the second power. How is 3 related to 8? That's 2 to the third power. And after we notice that, we can just multiply by 3, right? Why can we multiply by 3? Well, we have 3 groups. We have 3 groups, so that's where this 3 comes from. And 3 is the starting term, right? It's the 3 groups times 2, which is our multiplier, right? This is the change factor that we noticed here. And we need to raise that to the time, right? 2 being raised to the time that you're on with our 3 groups. So this is groups. This is our number of groups. This is our change factor. And this is our time. So once you figure out the relationship between the minutes and the number of dots in one of your groups, we can begin to extrapolate an explicit equation. So for now, I'll write number of dots is equal to our 3 groups times our change factor raised to the second power. And so for our recursive equation, let's start with our first term, f of 1 equals 3. And our next term is equal to our previous term times 2. We can also plot these points. In Open Up Algebra 1, I always recommend to count by ones here. Okay, count by ones here. So this will be time, our independent variable, and this will be dots. Oh, that was impressive. I can't believe I did that. Okay, so 0, 3, that's our first point. Then 1, 6, 2, 3, 4, 5, 6. Then 2, 12. That's 6, 7, 8, 9, 10, 11, 12. This is a little bit hard to see, but we will have this kind of growth here. We call this an exponential function, which we'll talk more about later. And there you have it. There's our table, our graph, and our recursive explicit equations. So at t minutes, let's zoom in here. Oops. At t minutes, we're looking at 3 times 2 raised to the t power. So at t minutes, we have 3 times 2 raised to the t power dots. So we notice when we have a change factor, we are talking about a geometric sequence, right? To get to the previous term, you need to multiply or divide by the same value. So here the multiplying number, the change factor, is times 5. And we just talked about the change factor here. So here the change factor would be times 2, times 2, times 2. So this would be an example of a geometric sequence. And you're multiplying to get to the next term. A common ratio, which is synonymous with the word change factor, it's the same idea, right? It's that multiplying number. Here the common ratio is r. So in the previous example, our change factor was times 2. We are also going to begin to call it a common ratio. So how are the outputs in the table in an arithmetic sequence like we saw in growing dots different from these? Well, in growing dots, our outputs pattern had a common difference. You have to add to get to the next term. In this lesson, outputs had a common ratio. So that is the major difference between these two lessons. Again, review this slide, okay? Focus on just one of the groups and how it's related to time. Focus on one of these groups and how it's related to time. How is it related? Oops. How is it related? It's powers of 2. So the minute, compare that to one of the groups, that's 2 to the first power, right? This is 2 to the second power. This is 2 to the third power, which is 8. And then 2 to the fourth power, which is 16. If that can be your only takeaway from this lesson, I would say it's a pretty successful one. So, hope you enjoyed this video. Hope you found it helpful, and happy learning. See you guys in the next one. Bye-bye.